Okay, so welcome back. Now what we're going to do is we're going to start talking about finding the angles, right? Finding the sides and calculating things for the special triangles. And we're going to start with the 45, 45, 90 triangle. So in this case, we want to find, hey, what if we have a 45, 45, 90 triangle, how does that affect our calculations, or not affect our calculations, but affect the results here of what we're going to get for x and y. Now, the one thing, remember, is that in this case, because we're dealing with a 45, 45, 90 triangle, this is an isosceles triangle. So in this case, the first thing we note is that x is equal to y. Okay? And so now what we're going to do is we're going to use the identity, right? And we're going to solve for x. Okay? And so also remember that because this works, right, we're talking about because we're talking about the unit circle, right, this 45-degree angle, is also, remember, is pi over 4, right? In radians, right? So 45 degrees is equal to pi over 4 radians, right? So we know that the length, right, because it's a unit circle, this length is also what? Pi over 4. Okay? But the main thing is we're going to use the Pythagorean theorem. Now that we have this, we know that this, right, for the unit circle is true, right? And so we know that since x is equal to y, this x squared plus x squared is equal to 1, which gives us 2 times x squared is equal to 1, which gives us x squared is equal to 1/2. And so now if we take the square root of both sides, we get x is equal to plus or minus the square root of 1/2, which equals plus or minus, well, the square root of 1 is 1, so we get 1 over the square root of 2. Okay? Which is also the same as y. Okay? Now, if we're in quadrant 1, which that's where we're in quadrant 1, then this is going to be positive. And also, again, because we have a square root in the denominator, we want to rationalize this, so we want to leave it like this. So we multiply the top and the bottom by the square root of 2, and this is going to give us square root of 2 over 2 for x. And it's also the same for y. So that is the result for a unit, for a 45-degree angle. Okay, so now, what's the conclusion? Okay, well, the conclusion is since we know that this is equal to cosine theta comma sine theta, then we know that cosine of 45 degrees is equal to square root 2 over 2, and sine of 45 degrees is also square root of 2 over 2. And that's the point. So we get the xy coordinates of a point on a circle of radius 1 at an angle of 45 degrees is square root of 2 over 2 comma square root of 2 over 2. Have a great day.